Hello, guys. Good evening. Hope you all are doing good. So, this is the third session of your data engineering interview series. I'm very happy to have you all in here today for this session. And I believe we all are going to learn something today, and it is going to help us during the interview. Okay? So, before we start our session, who are we? We are Data Valley, the fastest growing edtech company of 2025. And this is Franklin here who is presenting this. Myself, I have almost 3+ years of experience as a data engineer, and I'm very happy to share you with the knowledge and in demand and in on trend industry questions to you, so that it guides you and helps you to become a better data engineer. Or if you even it could be a fresher, and it is going to help you gain some knowledge about the interview, how it is going to be done. So you all know the routine. Grab your coffee, come sit and chill for an hour, and make sure you learn as much as possible. Okay? So this is our third part in this series. What are we covering today? So today we are starting with the SQL questions. Then we will be talking about data modeling. Then few big data tool questions. Then we'll be covering up ETL pipelines, and then to the cloud technologies. So I hope the agenda is very clear, and let's jump to our first session about SQL. The first question is, what is the difference between rank function, dense rank function, and row number? Okay, so this is commonly used in as a window function within the SQL. Okay, so rank, dense rank, and row number are a window function in your SQL. Okay, first talking theoretically, rank function will skip the ranks if there are ties. Okay, so what do I mean by that? Let's say there are 5 students in your class. Okay, and for instance, 2 students have got the rank number 1. So what happens while you use rank function is that the first person gets rank 1, the second person who has got the first rank will get the same rank. So 2 persons are getting number 1. So what would be the rank of the third person, or who has secured the second position? His rank is number 3. So whenever the rank is similar, the ties, whenever there are equal ties, the ranks will be skipped. So that's what happens in the rank function. So how is it different to dense rank then? In our same scenario as we discussed before, let's say there are 5 students in the class, and 2 students have got the position number 1. So what happens is the first person and the second person gets the rank number 1. The third person who has secured the second position gets the rank 2 still. So that's the simple difference. So in rank function, you get to skip the rank because there are ties, and in dense rank, you don't get to skip the ranks even though there are ties of rank values. I hope that is very clear. We will see that in the technical implementation as well. But just for now, try to understand the theory. There is no skipping. And another easy way you could remember this is rank, right? And this is dense rank. So you can just call it, or you can just name it by yourself, like, oh, the rank is densely populated. So what do you mean by dense? So you're not going to miss out on anything, and there is not going to be any space, right? So what do you mean by dense? You're not going to have any space, right? So it's very closed, very tightly packed. So same way, it's 1 1 2. So the rank is not getting skipped, even there are ties. So that's how you can remember these terms easy. And then you have row number. So row number is just like assigning a number to each row. So in our same scenario, as we discussed earlier, there are 5 students in the class. No matter what their rank is, no matter what how they are arranged. So let's say they are ordered in a way that 1, 3, 4, 2, and 5. Even in that case, it doesn't matter how unordered they are arranged, but every row or every student is going to get a unique number. Okay, so even their ranks or values could be ties, but even in that case, they just get an unique row number. All right. So ranks, you get to skip a rank when there are ties. And in dense rank, you don't skip a rank even if there are ties. In row number, even for ties, all you get is an unique number for each of the row. Simple. So let's see how this works in our code. So I've opened up my MySQL workbench. I'm creating a database called data engineering. Let's use the database, use data engineering. And here I have my sample table. So what have I created in my employees table? I have an employee ID with integer data type, department with text data type, and salary with integer data type. Okay. And I'm inserting few data into my employees table. So I'm inserting 5 rows, 1, 2, 3, 4, 5, and all of them are from the same department, sales, and this is their salary. So 5,000, 6,000, 6,000, 5,500, and 7,000. Okay, let's see how our table looks like. Okay, here is our table. So as you can see, 5 employees with unique employee ID. All of them are from the same department, and they have all got a different salary except employee ID 2 and 3. Okay, it doesn't matter. But just let's see how does our rank function, dense rank function, and row number works. So we are using Windows function. I'm selecting employee ID and salary, and then I'm using rank function over order by salary in descending order. So I'm using a rank window function, and I'm ordering it based on salary, and it is a descending order, and I'm naming it, or I'm using an alias called RNK. Next, I'm also using another window function called dense rank over my salary column. I'm ordering it by salary, and it is going to be in descending order, and I am giving an alias as dense rank. And then my third window function, it's row number function over the salary column. Again, it's ordered by salary, and it is going to be in the descending order as row number. In here, row number is my alias. So what's my table? It's from employees table. Okay, let's see how this code runs now. If you see here, so we have got an employee ID 52341. Okay, our rank function based on the descending order of the salary. So that is how we have done for everything, right? Salary descending, salary descending, salary descending. So it's going to be same for every Windows function. As you see here, 7,000, 6,000, 6,000, 5,500, and 5,000. And then because we have used rank function, see the rank in here. 1, because he has got 7,000 salary. 2 for 6,000 salary. 2 for 6,000 salary. And because there are 2 tie values, rank number is 3 is skipped. So it doesn't matter what number it is, but whenever there are ties corresponding to it, those ranks will be missed out. So in here, let's say I've got 3 ranks of 2. Okay, so 3 employees have got rank 2. So in that case, we'll be even skipping the rank number 4. We'll be just getting straight to 5. Okay, so it'll be 1, 222, and 5. But in our case, we have 2 tie values for the rank number 2. So hence rank 3 is missed out, and we are having 4 and 5th rank. Okay, this is rank function. So what did I say about dense rank? Dense, so it is tightly populated. So in that case, we can see here that for the salary 7,000, the dense rank is number 1. And for salary of 6,000 for employee ID 2 and 3, the rank has been given as 2 for each. And in here, we are not skipping a rank. So for 5,500, the rank is going to be 3. So in rank, we saw that they have got the position 4. But in dense rank, because it's tightly populated, they have got the rank 3. And for salary 5,000, yes, obvious, the rank is number 4 for dense rank. Okay, whatever order it is in, if you see the row number, it has just assigned unique values as 1, 2, 3, 4, 5. So it doesn't matter what rank or what dense rank, or what order the salary ID is in, or what order the employee ID is in. Right? For example, see here, for employee ID 5, the row number is 1. For employee ID 2, they have got the row number 2. For employee ID 3, okay, it's same, they have got rank number 3. For employee ID 4, they have got the rank number 4. But employee ID 1 has got row number 5, right? So it's all row number where you get to assign unique values just for all your rows in the column. I hope this is very clear. Now let's jump to our previous question, the next question. How does join differ from union? Okay, these are different functionalities that we use or perform in our table, mainly considering the fact that we combine or merge different tables. Okay, so it's a multi-table operation. Okay, when you perform a join, you are combining two tables. When you perform union, you combine two tables, not necessarily just two, it could be even more. When you assign what table to join and based on what key you're asking the table to be combined, so it can be more than two tables, and the purpose of join and union is to combine or merge two different tables or more. So how do they differ? Because both are multi-table operation, but how do they differ? In join function, you combine the rows based on the matching keys. Let's say you have two different tables and each are having a customer ID. In that case, you can match both of the table based on the common column called customer ID. If every keys are different, or let's say your keys are mismatching and there is no point of common value between two tables, then you cannot perform join. So we are combining here based on matching keys. And one key difference between union and join is more to do with horizontal merge. So you're not combining anything vertically, but based on the horizontal match, you're performing a join. Okay, how does it differ to union? In union, you get to add the rows, but in a vertical form. So you're going to stack your rows of data to another table. It's a vertical stacking basically. And if it is union, if it is just union function, you're going to remove all the duplicates. Let's say your table 1 has few columns, or I mean few rows, each with ID like 1, 2, 3, 4, 5. And they have another table and that has a value like 3, 4, 5, 6, 7, 8. In that case, when I do a join, yes, there is going to be vertical stacking, but the duplicate rows are removed and all you get is 1, 2, 3, 4, 5, 6, 7, 8 because the duplicate columns are removed and you're going to just have the unique ones. But in case if you're using union all, even the duplicates might get repeated in your vertical stacking. Okay, now let's see an example of how this is done in a code functionality. So if I have the table, I'm deleting customers. Okay, I don't have one. So I'm creating a table called customers and it is having three columns: customer ID, name, and city. So customer ID is having a data type integer, name is having a data type text, and city column is having a data type text. So I've created my table and then I'm creating a new table called orders. And orders table is going to have three columns again. So one is order ID with integer data type, customer ID with integer data type, and product column with text data type. Okay, I've created table orders. So two tables, customers and orders, and they have different columns, three different columns. Now I'm inserting few records into my customers table. So the syntax is insert into table name, values, and then you assign the values for each column. I've inserted the data into the customers. Similarly, I'm inserting data into the orders table. And now let's see how our table looks like. So here is my customers table. It's having customer ID 1234, and their names are Alice, Bob, Charlie, and Diana. And they are from the city Chennai, Bangalore, Delhi, and Mumbai. So how do my orders table look like? So in my orders table, you can see that I have unique order ID 101, 102, 103, and 104. Order number 101 was placed by customer with ID 1. Order ID 102 was placed by a customer ID with ID number 2. Order ID 103 was placed by a customer with customer ID number 1. Order ID 104 was placed by a customer with customer ID number 5. And what do each product correspond to? So order ID 1 is having a product called laptop. Order ID 102 has a product phone. Order ID 103 is having a product keyboard. Order ID 104 is having a product monitor. So let's do our join first. So I've given here first my select statement. Select c.customer ID. I'll let you know why I have mentioned c. I've mentioned c.name, c.city, o.order ID, and o.product. Okay. So before jumping to that, I'll show you something else. So at the bottom, okay, after your select statement, if you see here, I've got from customers C, join orders O on c.customer ID is equal to o.customer ID. So what I've done is, for my customer table, I've given a new alias called C. For my orders table, I've given a new alias as O. How does this benefit? Okay, in my query, if I'm using these kind of short aliases, it'll be easy for me to write a larger code. So instead of mentioning every time customers.custom ID, customers.name, customers.city, orders.order ID, orders.product, I can easily mention the aliases that I've used. So what is my alias? So my alias is C for customers and O for orders table. So in here, if you see, I've used dot notation to tag the column along with the table name. So table name, column name, table name, column name, table name, column name, table name, column name. So I've tagged each columns to each of the corresponding table. And also there is another scenario where you might have different columns in different tables having the same name. So in that case, if you use the alias, you're going to avoid the ambiguousness in your data, so that your database is not going to confused of which column it needs to choose to get the result that you have inquired about. So I'm selecting from the table from and join, and this is one of the crucial step in join, because in join you have to select two columns, that is one column from each of the table where they have a match. Okay, in here I've chosen customer ID from my customers table and customer ID from my orders table. Let's see how this code runs. If you see here, I've got Alice with city Chennai and their order ID and their product. For Bob, I've got along with the city, order ID, and his product. And for the next row, we have got Alice, who is from Chennai with an order ID 103, and she has ordered keyboard. Okay. Now, how is it different to our original table? So we had four different customers: Alice, Bob, Charlie, and Diana. And in here we have only the customer ID 1, 2, 1, and 5, right? So 5 is so customer ID with 5. But if you see our customers table, we don't have customer ID 5, neither his name. So you can see the difference, I believe. So one is corresponding to laptop, two is phone, and customer ID one has got keyboard. So that is our orders table. So now what happens with our horizontal merges, and because O dot customer ID, okay, it has number 5, but C dot customer ID doesn't have number 5, right? So customers table doesn't have our customer ID number 5, but orders table with customer ID has number 5. So in that case, it's a mismatch, and that's why we are not seeing it in our joint table. All right. So make sure the column you specify from both different tables are matching. Okay. Jumping to our union. So union performs a vertical stacking. So let's see how I have done it. So I'm running a select statement, and then taking the column name. I'm giving an alias as info from customers table, and I am unioning it with select product from orders table. So let's see how our table looks for a better understanding. So we're having three different columns: customer ID, name, and city. And in orders table, we have order ID, customer ID, and product. And when you run union, I'm just selecting name as info from customers. I'm just selecting the name. And in products table, I'm just selecting in orders table, I'm just selecting the product name. So my result comes in the following way. So we have chosen single column from each of the table, that is customers and orders table. And from them, you can see that Alice, Bob, Charlie, Diana from the table 1, laptop, phone, keyboard, and monitor from table 2 have been merged but stacked vertically. Okay, this is the main difference between join and union function. What's a window function? Give a use case. So Windows function helps you to perform calculations across a set of table rows related to the current row. Performs calculations across a set of table rows related to the current row. So first thing, what does it do? It does some calculation. Okay, you might have a question now. Okay, so how is it different to any other different aggregate function or whatnot? We have different functions, right? Like sum function, we have count star, count function, we have average function. So in that case, how is it different than window function? In Windows function, you can still use your aggregate function, okay? But the main difference is that you create a window. So as the name suggests, it's a windowing function. So what happens with the window is that instead of collapsing your rows, okay? For example, in a normal query, when you run group by, what happens? Hello? So I hope you all are paying attention. And so what's happening is that when you run a group by in a normal query or a simple query, let's consider an example like a department with employees in it, and there is only two departments. So one is sales department and another one is marketing department. In that case, when you group it based on the department called sales and marketing, so from the 10 rows that you had as a whole, your number might differ, right? For example, depending on your cardinality. In our case, we have only sales and marketing cardinality, so hence the employees will be within each. So you're running count star, sum function, average, anything, but this is how it works in a simple query. It just collapses all the rows and gives you just the value. But when you consider the windowing function, your window function will not collapse any rows. So there is not going to be any collapse of your rows. Your data is going to be preserved, and in a separate new column, you're going to get the aggregated value, okay, from your current row. So window function works in a time or a time frame, sorry, the window frame or the window size frame from your current row to your previous rows, or from your current row to the following rows. So the definition is performs calculations across a set of table rows related to the current row. So you perform calculations from your current row. So for example, you might use an average function. So average function as in a simple form is a aggregate function, right? So I'm insisting here an aggregate function, and when I use an over clause, it becomes my window. Okay, so what is my window? I want to partition it by region and order it based on the month. Okay, so this is the window function. And the use case is when you don't want to collapse any of the rows, but just you want to have a moving average, let's say, or you want to have a moving calculation or an aggregation corresponding to your current row. So that's when you use your window function. Jumping to our second session about data modeling. What is a slowly changing dimension? As a data engineer, we might be hearing a lot of terms. Rather than memorizing them, try to be very clear about learning from the topic or learning from the heading itself. So learn it as a sheer meaning so that you don't have to remember much, or you don't have to look for a dictionary or any website to give an excessive description. So from this name, maybe from next time you can remember it because I'll explain it for this time. So the name suggests slowly changing dimension. You all know what is slow, right? Slow, it is something that is having a slow pace. Okay, it is going to change very infrequent, it is going to change very minimal, so that is slow changing. Okay, so you're changing something slowly. Okay, what am I changing slowly? My dimensions. Okay, what do I mean by dimensions? So there are two types of uh, how can I call that? I would say that as a two different type two different types of table within a schema. Okay, the one is called dimension table and the other one is fact table. For a simple difference, let me give you this. The dimension table will have your referential data, or it is going to have a contextual description, or it is going to have more of a descriptive kind of data. And your fact table, it's all filled with fact. So what do I mean by fact? So it can include transactions, it will include your numerical data basically. So that's what I mean by facts. So facts is going to have numerical data, and the dimension table is going to have your contextual or referential data. Okay, so this data is getting changed. So this is the meaning of SCD. Okay, but let's dive deep technically to know its definition. SCD tracks historical changes in a dimension table, and it is useful in data warehousing for slowly evolving attributes. So I've explained you what is a slowly changing dimension, where your data gets changed in a slower pace, and this helps you to track your historical changes in your dimension table, because each time when there is a change, you update your new record or you update your existing record, where the older versions of your data get a number, the version number I mean, or the older data will get a date where this was last used and it becomes inactive. So it's better for audit purpose. So that's what I mean by it tracks the historical changes in dimension table. And it is useful mainly in data warehousing for slowly evolving attributes. What are the types of SCDs? So we have seen what is SCD, and now let's see what are the types of the SCD. So SCD is of three types, sorry. So it's type 1, type 2, and type 3. Type 1 is where you override the old value with a new one, and type 2 is where a new version is included. So the new row gets added up again and again in your table. And type 3 is where a new column gets added, and there is another column that has only your older value. So basically, it has only the partial history. So let's say a customer calls Franklin So he's giving himself for a loyalty program. Okay, so he's going to Walmart, and Walmart is having a loyalty campaign. So for that, Franklin is enrolling his details. On day one, Franklin is telling, "Oh, my phone number is 111 111 111." Okay, cool. Next day, Franklin is again going to the store and he's telling, "I've updated my phone number. Can you please change it? And my new phone number is 222 222 2222." Okay, I've updated. And on day three, Franklin is telling, "No, no, no, no. Please change this. I've got a new number, and it is 333 Okay, so that's how this is a common scenario. Just try to remember this. And now I will explain this in context of type 1, type 2, and type 3. In type 1, your existing data changes to only the newer one. So when I change my phone number from 111 to 222, the 111 data gets erased completely and there is no version history, just it gets updated to 222. In type 2, when I change my number from 111 to 222, my existing phone number that is with 111, so that data gets inactive because I assign values like what was the start date of the data, what is the end date of the data, is it current now? So I'll be updating those kind of columns in my type 2. So when I update my number again from 222 to 333, even my 222 phone number is saved, but it just get updates to 333 phone number. All right. So all my history of all my changes, all the versions of my data get stored in the type 2. So what happens in type 3? So type 3 is where your, let's say in our same scenario, 111 to 222. Okay, because I've changed from one number to the other, so there is going to be one column that is going to have my old data and my existing data. So my previous value will be 111 111 111, and my old, I mean my, oh, sorry. So my new value will be 222 222 222, and my old value will be 111 111 111 Are you all right? So then, let's say Franklin on his third day changing his number to 333 In that case, the old value is 222 and my new or current value is 333 So what happens to my previous data, the 111 So in type 3, you just delete it. So you're going to have a partial history of your current data and your last made change in your database. Okay, so these are the types of SCD, and you design the SCDs depending on your business requirement. As you see here, I got type 2 slowly changing dimension. You can see the changes in here, right? So 10-inch box is a 10-inch box previously. Okay, my 12-inch box. So it is having 12-inch box, 12-inch glued box. So it's my effective date from Jan 1, 1753, and it is ending on some date. Okay, forget about the date value, but yeah, just remember it. So I've given my second row as well, which is product source ID 10, and it is having 10-inch glued box, effective on the date, and the effect end date. Now I'm updating it to, it's no more 10-inch glued box, but rather a 10-inch box, and it is 10-inch box. I've added this as well. So what happens is I'm creating a new row with the following information. So it's my SID is 3, and then my source product ID is again the same, but with changes. Now you can see it's 10-inch box because I've struck out glue. I've updated it, and it's 10-inch pasted box, and it's effective from the date that it was, the previous record was end. So this is my effective start date, and this necessarily doesn't have to be full unless when you make a new change. So here you see how do we update. using a CD strategy. You have type 1, type 2, and type 3. Initial load for all of these, but type 2 is having additional columns that can track and establish, and type 3 is having columns like history columns when it was established. So now a new data is coming, okay, and you already have your table. Is there is a match? No. In that case, load my new record. Okay, I'm getting new data again. If there is a match, yes, okay. If there is a match, replace your old record. Okay, so you're just going to replace your old record and not going to maintain any history. This is type 1. Type 2, I'm having a new data coming up. I'm asking a question. Is there is a match? No. If there is a no match, load my new records and mark old version as obsolete. Okay, again, new data comes through. You ask a question, do I have a match? If the answer is yes, okay, so detect the changes and add the new version. For type 3, okay, I have my database and now new data is coming up. I'm asking a question, do I have a match? And if the answer is no, okay, just load my new records. And if there is a match, so change is getting defected, and then you change this table. And you can see here that once the change is detected, I am modifying the changed records. So for example, I have a new data, and with that we correspond to the current date, okay, and now it has become effective from that day. You're just having one of the previous value and you're eradicating all the previous value, or in other words, you're just having the current value and the last changed value. Okay, so this is the difference between type 1, type 2, and type 3 SCDs. Jumping to big data technologies, what are Parquet and ORC file formats? So both Parquet and ORC file formats are columnar formats. Okay, and both of these file formats can be compressed and they are splittable, and they enable us to do predicate push down. Okay, so what do I mean by predicate push down? Predicate push down is where you filter as early in your query so that you're not going to fetch all your data, or full table scan is going to run and cost you your performance and money. Okay, we have seen the common things between Parquet and ORC. So what are the difference there? Parquet is mainly used in Hadoop and Spark and Hive. It is columnar, which is common, and then it is good for analytical workloads. And Parquet is specifically useful for read-heavy workload. Coming to ORC, ORC is optimized mainly for Hive framework, and it is better, and it has a better compression for Hive workloads. Okay, these are the major differences between the Parquet and ORC file format. Here and I've got a big table for us to understand this better. Feel free to take a screenshot and have a look at it later as well. So both the data storage style is columnar. Okay, it both stores in columnar data format. What is the compression? When applying compression on a Parquet, it's efficient, but when you apply a compression on ORC, it is a notable overall compression with lightweight indexes. So both supports compression and both supports the schema evolution. And for Parquet, you have extensive community support in comparison to the ORC. Parquet doesn't support asset transaction, or it is not therefore a lot of community support, or it has less support basically. But leaving about the community support and talking about the asset transactions, Parquet has less support and ORC has full support. So it enables ACID transaction in your Hive database. It is both ideal for large data sets, yes, because compression happens, it supports splittability. So considering these factors, it is very ideal for large data sets. How efficient are they for small data sets? Less efficient due to columnar nature for smaller data set, and it is less efficient due to columnar nature for both of the ORC as well. What is the ideal workload type? Parquet mainly supports read-heavy analytical workloads, and ORC mainly supports write-heavy workloads and tasks involving data modification. I just explained it to you that it supports the ACID compliance or ACID transaction in your Hive data warehouse, right? So when it enables ACID transaction, what does it mean? It is a write heavy workload, right? So it helps with write heavy workloads. What is the performance and analytics? Parquet is exceptional, especially with tools like Apache Spark and Apache Arrow. But talking about performance and analysis for ORC, it is okay is good, and it is particularly with Hive-based frameworks only. So I would consider Parquet anytime, all day. What is Hive and how is it used? Hive is an open source data warehouse project. So this is the logo for Apache Hive, and Apache Hive is a data warehouse software project. So the open source data warehouse. It is built on top of your Apache Hadoop, and since it is built on top of Apache Hadoop, it fetches data from its Hadoop clusters, and then it supports data query and analytics. And one good thing about Hive is it supports Hive SQL, okay, which is a little bit different to the normal ANSI SQL that we have. So Hive uses HQL, or you can call it as Hive SQL. So though there are slight changes in the syntax, it's more like an SQL-like interface to interact with your data. So Hadoop, what is a Hadoop? It has basically a SQL engine under the hood. Okay, so under the hood, it's another SQL engine to run your queries. And Hive is especially suitable for batch ETL and data warehousing queries. And Hive supports HiveQL or HQL or HiveSQL. So these are the different what is that the ways that Hive is used for. Okay, so mainly for analytics, I would say, because this is an open source data warehouse. What is the difference between Kafka and Flume? Let me drink some water, my throat is very thirsty. So what is the difference between Kafka and Flume? So Kafka is a distributed streaming platform. Okay, so you get to stream your data using Kafka. In more or less, it's a real-time streaming platform. Okay, it provides high throughput and real-time pipeline. So it helps in high throughput of the real-time pipeline. So what happens with Kafka is that so producers will produce a message, brokers will collect this message, store it and handle it, and consumer is anything that consumes the data from this broker. Okay, so as you see here, producers are applications that write data to your Kafka topics. So what happens is you create Kafka topics, and the producers they write data to all these event topics. Okay, so these Kafka topics, so based on PubSub, whoever has subscribed to these Kafka topics, okay, they get to read from these Kafka topics. Okay, so from Kafka, the data is written to Kafka topic, and brokers are the servers that manage and store and handling of your messages, and consumers are applications that read data from Kafka topics. So how is it different to Flume? So Kafka is real-time streaming platform, but Flume is a log data ingestion framework. Okay, so your data, it's your log data. You use Flume to ingest it to different sources. Okay, so source produces data. Okay, so source is the one where the data is produced, or where the source is brought in, and channels hold the data, okay, or the logs temporarily, and sinks they move where the data needs to be moved to. Okay, so what is the main use of Flume is that it is mainly used to push logs to HDFS. Okay, Kafka is for real-time streaming pipelines, and Flume is for log data ingestion purpose. Jumping to our fourth part, ETL pipelines. Difference between batch and streaming ETL. This is a very important thing. And when you start learning data engineering, first you'll be starting with batch, because batch is a bit easier in comparison to streaming ETL. So make sure you're aware about this concept. So batch ETL is where your ETL jobs run in a scheduled and periodic way. So let's say I run a retail shop. I open my store at 7 and close my shop at 11. So in between those hours, I'm going to have my transactions happening in my database, right? So all these data from morning 7 to night 11, these data will be processed or pipeline will be constructed or ETL will be performed. Okay, that's why I call it as an ETL job. So ETL job, what it does, it extracts the data for all these 15 hours. It transforms it or processes it and then loads it to the target. Okay, so but how is it different to streaming is that it happens in a scheduled periodic way. In the scenario that I told about, let's say my shop is closing at 11, I might fix my ETL job to run at 11:30 p.m. all day. Okay, so every day, so I'm going to have my ETL job run at 11:30 for my data. Okay, so it's very scheduled and it is very periodic. But when you talk about streaming, it's real-time data processing. For the same scenario, I open my shop at 7 and close at 11. And there is a transaction happening at 7:01. So morning 7:01, I'm having a transaction. So once the transaction is through and it gets loaded into my database, my ETL happens just immediate. Okay, it gets triggered immediately. So even it could be one transaction or whatever, for that minute it just gets processed immediately because we have set it to be in a real time processing. So batch process the data in a batches. It depends on what batch you set. It could be one day, it could be 6 hours, it could be 12 hours, it could be weekly, monthly, yearly. So it all depends on your business requirement. So because it is batch, you can handle large volumes of data at once. And because it is a batch, it is going to have an historical data, and hence it is easier to debug as well. Talking about streaming data or streaming ETL, and because it is continuously getting ingested, there is no chance of you getting larger volume of data. Okay, even many transactions can happen at simultaneously at a moment, but even in that case, your continuous ingestion comes into play, and each time your data gets processed real time. It is very complex and needs checkpointing. What do I mean by complex and checkpointing? So because this is very historical, you can store your data and you can debug and then transform it slower. But because you're processing the data in real time, it is going to be very complicated because you might have a lot of issues coming up, like schema evolution, data mismatches. It's a bit complicated. And you need to set checkpointing as well, because checkpointing ensures that you set a watermark and you don't process the data repeatedly again. Okay, so you set a checkpoint and you process your data beyond this checkpoint. So what are the tools for the batch? You have Apache Nifi, Talent, ADF, Azure Data Factory, AWS Glue, and Elastic MapReduce of AWS. And for streaming service, you have Apache Kafka, you have Spark Streaming, and you have Flink as well. The next question is, how do you handle schema evolution in ETL? So, what is a schema evolution? Schema evolution is where your data gets evolved periodically. Okay, let's say today you have only a data set with 3 columns, and tomorrow I might get a new data set with 4 columns. Okay, with each time this happening, so how are you going to handle it? So how are you going to manage it? So that is all about this. So how you're going to handle it? So you can use Avro and Parquet format. So what happens with Avro and Parquet is that your schema gets registered. Okay, and for each time when the schema is getting evolved, the schema registry will have its versions, and instead of breaking the ETL flow, the data pipeline or ETL pipeline will happen. So you can set the settings later. So in worst case, it'll at least load the column and will set it as null values. Okay. So your schema evolution can be handled well with Avro and Parquet. Why did I mention only Avro and Parquet? Because in other formats like CSV and JSON, you don't get support for schema registry. Okay. So you don't get support for schema evolution, and you allow optional and nullable fields. So that's what I meant. So when your schema is getting evolved, you have a new column, and let's say your data, and it's just evolving and you haven't approved it, and in that case your schema gets evolved, and for that column you store nullable, and in case if the data type is working out, you can store the optional data fields as well. And then with the benefit of using Avro and Parquet is, and because it is using schema registry, you can track your schema versions as well. So make sure that you use Avro and Parquet with schema registry, and then make sure you allow your nullable and optional fields in the file system, and then also make sure that you track your schema version. What if by chance you don't want to have a particular column? Okay, you want to enforce a schema with only just three columns as usual, you don't want nothing more than that. So in that case you have to track it, so you want to roll back, right? So that's why you need to track your schema versions. Next question: what are the common failure recovery strategies? Okay, there are chances that your ETL might fail, and how do you know perform a recovery strategies? Okay, so how do you perform a recovery for your failures? Okay, so my first answer is retry on failure. You can perform automatic retries. For example, if you are running a glue job has a mechanism to rerun based on the number of retries that you set. Why does it help you? Let's say in case there was a network issue. Okay, because of a network issue, your ETL job got cancelled, and now your network has become stable. And when you try to retry to run it, there are chances that the failure is recovered and the ETL pipelines work properly. You know, retry is a very common mechanism that we enable in our real lifetime. Let's say your mobile is stuck, it's just frozen, the screen is frozen. What do immediately? You just press the power button down and you turn on the power button again, right? So what is that? It's a retry, right? So you're just turning off and turning on. Similarly, with each job failure, what you're doing, you're trying a retry option. So okay, this thing didn't work, the ETL didn't work, let me cancel it and let me run it again. Next, you can set dead letter queues. What do I mean by dead letter queues or DLQs? So the problematic records can be sent for a manual review using a special queue. Okay, only the problematic records. And when I send the problematic records, okay, for the review, at least my ETL pipeline is prevented from halting. So that is why you need to set dead letter queues. Okay, it's a queue especially for your problematic records. Okay, that's why I meant as dead letter queues. Then you can set checkpointing. What do I mean by checkpointing? I just mentioned it earlier, right? So it's like a watermarking for your last stage of ETL. When you run your ETL job, you can save the progress periodically. Okay, and especially for streaming, checkpointing is a must. So what happens is you run your job, there has been some failure at some point, and now your job has failed. So instead of restarting the entire job, okay, so somewhere in the midway your ETL job has failed, and now instead of restarting, because you have set the checkpoint, your job starts running or restarts from the point where it has failed. So instead of starting from the very first process, it restarts only from the point where the progress was lost. So checkpointing is one of the common failure recovery strategies. So some of the best practice you can follow is you can use combinations of retry mechanism. You can set DLQs or dead letter queues for your bad records, and at the same time you can also set checkpointing for recovery in long running jobs, because sometimes your jobs might run for like an hour. In that case, if you rerun your job and you're going to have, again, some failures, you can't wait till the 30th minute to see if the job is running or is not working. So at least you get to refine your workflow, and you could process only from the point of failure, hence saving your time, right? So that is one of the recovery strategy. So try to use those in combinations. Jumping to our last session of the day, it is cloud technologies. Our first question is, what is Azure Data Factory? So Azure Data Factory is one of the servers from Azure Cloud Services. Okay. So what does this do is, it is an managed ETL service. Okay. So it is an ETL orchestration tool. So what do I mean by Azure's managed ETL service? So what do I mean by managed ETL services? It's a serverless, or it is a service managed completely by Azure, and all you got to do is write your code and just use it. Okay. So it's managed completely from the Azure's end, and you just have to use it for your workflow. So it's a managed ETL service. So using ADF, in short, you can connect it to cloud and on-prem. So you might have your data on-prem, or you might have your data in the cloud, or your target could be a cloud, or your target could be an on-prem. So in any different cases, you can connect to it and you can start performing the ETL. And ADF supports orchestration, transformation of your, and it also helps in the construction of pipelines. So Azure has features like to orchestrate like what time it has to run. So in ADF also you can write your transformation codes, you can write your transformation logics. It is applicable both in visual formats, or you can write in your code format as well. And then it helps with the easier construction of pipelines as well. So in case you do not know coding, I mean, as a developer you must be knowing about coding and stuff about how to construct the ETL. Do not worry about this, in future we'll be covering in our series. But talking about ADF, it helps you easier to construct a pipeline. So that's what I meant by visual pipelines. In short, ADF is used for your data movement with transformations. Okay. And now to our second question of cloud technologies. What's the role of IAM in cloud data platforms? So IAM stands for Identity and Access Management, and IAM is a very must security role, or it plays a very crucial role for the cloud data platforms, because you need to ensure that your data, your pipeline, your source, your networks, your applications, they are secure. So you use IAM to secure all these. So it's an access control framework. So why do I mean an access control framework? Because framework always has multiple components, right? So using IAM, you get to define the roles, you get to define the permissions for each role, you get to define policies, and you get to define the policies applicable for each role. You get to deny certain policies or certain access to certain roles. So it comes with multiple components and hats under it. So you can define your permissions and roles as well. And it is a easier key to to provide a secure cloud source. So using IAM, not everyone gets to access your cloud data platform, right? So it is a secure way and to access your cloud resources. And one major benefit of AWS IAM is you get to provide a role based access. So for example, let's say a sysops engineer, okay, he needs to implement a system. So his main work is to get the technologies running. Like let's say he needs to initialize an EC2. Let's say he need to start a virtual machine. So these systematic implementations must be handled for sysops, and he must not be having any access towards your data, right? So that is the role based access. But in case of a DevOps engineer needs to have access to all reliable or whatever the sources that he gets to implement. For example, he can use Kubernetes, he can use Docker. In that case, he gets the access to initialize those kind of sources. But sysops need not have access to other sources. For example, a data engineer, I do not need an access to Docker or Kubernetes unless I have an explicit role in my company where I need to work on these kind of different tools as well. But mostly in our case, we'll be handling data, storage services, databases. So I need to have access only to these resources rather than unwanted resources. So it's a role-based access for different resources. And my final question for the day is, what is serverless computing in data pipeline? So you all know what is a data pipeline, right? What is a pipeline? What is a pipe? So pipe is tool, something that you use to create a flow between two different sources, right? So pipeline is how you connect two different sources and you make the flow of a data. Okay, talking in data engineering context. So data pipeline. And what is serverless computing in context of data pipeline? Before jumping to that, what is a serverless computing? Does this mean that you don't get to have a server? Or does it mean that you're not going to use a server at all? No. What it means is that you're going to use a server, you're going to use uh, what I can say, you're going to use a system that hosts the server. But how is it different to server and serverless is you don't initiate the server. Okay. For instance, let's say you're running an EC2 machine and then you're launching an application. It's a server computing because you are initializing server from your end and then you're running an application on top of it. But in case of serverless, let's say AWS Glue, okay? And AWS Glue is an ETL pipeline tool, right? It's a managed ETL pipeline tool from AWS. So it is a serverless tool as well. AWS Glue uses servers behind the hood, but you don't describe, oh, I need this configuration, oh, I need this much cluster. You don't define it, but rather you just put your code logic and you get your code running. So you don't get to assign server. You don't have to worry about it. You don't have to worry about scalability. You don't have to worry about initializing, nothing. So serverless computing doesn't mean that you don't use server, but the key difference is that you don't initialize a server or you don't maintain server from your end, but your main priority is to work on the logics and code and get the pipeline or whatever other functionality that you want, you get it running. So serverless computing is a cloud execution model where you don't manage servers. You just write your code and the cloud provider runs it on demand, scaling it automatically scaling it automatically. So as I said earlier, it's just an execution model. Okay, you don't manage server, it is maintained from your cloud provider, and all you gotta do is just write your code, write your logic, put it in the server, and it gets you running. You don't have to maintain about providing in provision of your infrastructure or scaling it, connecting it, nothing to worry about. So in data pipeline context, what it means is that you trigger processing automatically when new data arrives. So when new data comes, each time you don't want to be initializing a server. You want to wait for it, and then create a cluster, define your nodes, and then you configure the machines, and then you write your code, and then it's a tedious process, isn't it? So this is very simple. You trigger processing automatically whenever your data arrives. You don't have to worry about scalability because it's a serverless computing. It is taken care by the cloud provider. With instant scaling, this is an amazing feature from the cloud service provider to we consumers. So focus only on your data logic, not on provisioning, deploying, or maintaining infrastructure. So zero worries about infrastructure, but our key functionality or focus is more towards the logics. What are the key concepts? It's a functions as a service. So what do I mean by functions as a service? You focus on your function. You work out on your logic. So you work out on the best implementation of your code logic about the better or you focus mainly on designing a better pipeline. Okay, it is auto scaled, which I said earlier. You don't worry about provisioning. You just take care of writing a logic, and that is maintained default by your provider. It could be any cloud provider, not just AWS, even for Azure. As long as it says serverless computing, it is auto scaled. It is event driven. So whenever the data comes and falls into your uh, the the dumping place, that data gets processed. It's event driven, right? So your data gets put and your pipeline gets triggered. So we use AWS Lambda in case. Okay, it's just an example. You can use multiple tools, but AWS Lambda is a perfect example. So it's event driven. The data falls, the AWS Lambda gets triggered. It's a serverless computing tool from AWS, and the process gets running. So you don't have to maintain any infrastructure. So that is the key point of serverless computing. It doesn't mean that you don't have resources, or you don't have provisioning of compute sources. All it means is that you don't maintain the infrastructure. As a cloud provider, they will maintain it for you. They will manage it for you. They will provision it for you. They will deploy and maintain, make sure all the security patches are fixed, make sure the compute resource is readily available. But from your end, and for the serverless computing, all you need to focus is, I write a better logic. I want to write a better code. And I want to make sure that my pipeline runs very efficiently with no problems, or it could scale automatically. All you have to go focus on is just that. So that is serverless computing in context of your data pipeline. So that is all for today. I hope you all enjoyed it. Feel free to drop a like. And if you have any doubts, or if you feel that you need to give us some suggestions, do drop your comments in the comment section. And feel free to share this to your fellow aspiring data engineers, so that they might find it beneficial when they are attending their data engineering interviews. And do subscribe to our channel so that you don't miss on the regular updates, regular videos being posted in our channel. Also, from our end, we publish multiple subjects, so feel free to check those as well. So some subjects like ethical hacking, Java developer, Python developer, SQL developer, MERN stack developer, full stack. So we provide multiple subject streams as well. So feel free to check that out. And we are Data Valley, and we have our headquarters in US, United Kingdom, and Hyderabad. Do check out on our website to know more about us, and feel free to ring if you have any queries and concerns. And good luck with all your preparations for your data engineering. And we also have many series coming up, so do check out. And I hope this video content helps you to ace your next data engineering interview. So good luck. Happy to have you all here. Thank you so much. Until then, this is Franklin signing off. Thank you so much.